All right. Hello, everyone. Thank you for tuning in to today's Corundum developer meeting. I'll go ahead and get started. I got some announcements and some status updates. So basically for the announcements is the results of the survey. There's only 10 responses, so not a whole lot of data to go through. Basically the consensus from what everybody who actually went in and clicked the buttons reported is that most of the options are probably pretty workable, except for the alternating 9 a.m., 9 p.m. Idea that I had. I wasn't very happy with that one either, but I decided to put it on there just to see what people thought, and people didn't like it. So okay, fair enough. So basically there were 8 votes for Monday, 7 votes for Wednesday, and I didn't hear from anybody like in Asia, basically those kind of time zones. So I'm thinking most of those people probably are only going to be able to hit the 9 p.m. time slot. So um, considering that that they're similar number of votes for each one, I figured okay, we'll go ahead and go with the Wednesday idea. I mean, we got definitely more than half for each of those, so I think it'll work pretty well. Or we'll see how it works. I can certainly adjust things if necessary. And I put down 9 p.m. for the second slot. We could certainly move that a little bit earlier or a little bit later, depending on what works for people. And like I said, nobody is under any obligation to attend both. You can hit the earlier one or the later one. I mean, obviously, it'd be better if we just have one slot and have everybody, but with people spread around the world in multiple time zones, that's probably not really realistic unless people are going to be logging on at 3 or 4 a.m. locally. So um so we'll see how this works. So I have the meeting dates listed here. February 7th will be the first one, meeting on Wednesday, and then the first Wednesday of every month after that. And I guess another thing I should say is that if people like doing meetings a little bit more often, I could potentially do like the first and third Wednesday of each month, something like that. Um, the idea is also to get rid of kind of the phasing thing, right? If it's every other week, you got to know, okay, was there one last week? I don't know. But if it's the first and third Wednesday, you can just pull up your calendar and go, okay, we got one this week or whatever. I'm also going to go ahead and put together a Google Calendar with this schedule, such that people can add that to their calendars and get a reminder or whatever without having to jump through a bunch of hoops. So that's about it in terms of the announcements here. Next meeting for the developer meeting will be on February 7th. Switch developer meeting at this point, we'll see about that. Maybe we'll just do it the week after or something. But yeah, that's it in terms of announcements. Moving on to the status updates. All right. So I've been doing a little bit more optimizing on the Mac and Fi side as we're trying to get stuff to fit on our FPGAs here at UCSD. Trying to squeeze out a little bit more timing slack in the high speed 25 gig clock. I've also been working on the updated scheduler and internal flow control, and there's some sort of research code that I've gotten basically cleaned up and into the repository in terms of some of the bit error measurement stuff. So I got a couple slides on that. Application section pass through, I guess, is still a work in progress at the moment. And then testbed status, I've done a little bit more work on getting that set up. So let's go through these. Mac and Fi optimizations. There's a couple of things that I was chipping away at here. I reworked some of the termination control character detection in the receive direction. I did this, or something similar in the transmit direction, to basically reduce this big case statement, reduce the number of bits that it's looking at. So basically, I reduced it from 8 bits to basically 3 bits to indicate where the termination character is, plus 1 bit indicating that there is one. And the idea is it'll simplify the downstream logic and reduce some levels of logic because you don't need as many LUTs to decode the input. I also did some work to rework the framing error detection as part of that. Yeah, okay. So I reworked the termination control character and then I reworked the framing error detection just to simplify a couple of pieces of logic. And one thing that I'm doing there is I'm pulling out some of the framing error reporting into a new state, which should simplify some of the internal logic a little bit. Just anything to simplify the logic and reduce the footprint, improve the timing performance. That's going to be useful. I think right now the transmit side is much larger than the receive side. I'm not sure if there's much I can do about that, but you know, something I've been chipping away at. As part of this, I'm also adding a couple of additional tests, basically to test what happens, or that the Mac works correctly when there's an underrun, T-valid falling in the middle of a packet, and T-user assertion for indicating a bad frame. And as part of this, I found a bug in the Gigabit Mac related to underrun. So that's going to be fixed, and then these tests will be added along with some of these other updates and modifications. So I think some of this is up on the Ethernet repository. I haven't pulled it back into Corundum yet, but that'll take place relatively soon. All right, so moving on to the scheduler and internal flow control. All right, so this is something that I've been talking about for past couple of meetings here. Basically, we need to be able to support multiple ports and multiple priorities in the scheduler. And if we can support multiple ports, then you can have one scheduler for multiple ports, instead of having to have multiple copies of the scheduler, which should reduce the resource utilization. The long-term goal is to use linked lists to efficiently store all of these basically internal FIFOs, and use multiple entries per list element to hide pipeline delays. But probably the first iteration is not going to use linked lists, it's going to use normal FIFOs, which will be less efficient, but a little bit easier to get all of the other stuff sorted out. And then the linked list will be kind of an optimization to reduce the footprint. The other component of this is the internal flow control. The scheduler has to prevent head-align blocking by managing all of the in-flight transmit operations on a per port and per priority basis. There needs to be a way to adjust that from the driver, so you can figure out how much of the transmit buffers you want to allocate to each priority level and whatnot on each port. And status of this is very much in progress. That's kind of been backburnered for the moment because we're working on paper deadline at UCSD, but as soon as that's squared away, then I'm going to get back to chipping away at getting this finalized. So one component of this is the new scheduler, and multiple. To make this work, there's going to be multiple levels of scheduling. Basically, we have to do round robin across the ports. We have to do priority scheduling across the TCs that are assigned to each port, and then round robin scheduling on the queues inside of each TC. Queues can be scheduled on multiple ports, but only on one TC per port. So this is kind of similar to how things were set up before, where we had multiple instances of the scheduler that were totally independent, one per port. So you could schedule queues on all of them if you wanted to. So I was thinking about originally, okay, we'll just make it so you can schedule queues on one port, but then you come into issues in terms of, well, what if you want to migrate a queue from one port to another? Then you basically have to, that complicates the logic for how you handle that, because are you going to wait for the queue to pop out of the scheduler on the first one before you reschedule it on the second one, or are you going to have some more complicated state to track that? And if you migrate it across multiple, that's going to increase the state storage for keeping track of everything. So it seems to be a little bit cleaner if we just keep everything separate, such that you can assign the queues on multiple ports if you want to. Right, and then the other component is we need the internal flow control to manage the buffer space. You can only start a transmit operation if you have space available for that packet, and you don't know how big the packet is until you've actually started the operation. So you have to assume the worst case, that the packet is going to be a whole MTU, and then potentially you can reclaim some of that buffer space once you know how big the packet is. And this needs to be done on a per TC per port basis. So I'm calling that a scheduler channel. Each channel has to keep track of its own flow control. Right. And then for the internal flow control, we need to enforce a byte limit and potentially a packet limit Like I said, we don't know the size of the packet till it's being sent, so we got to assume the worst case. But if we always assume the worst case and we don't do anything to reclaim that, then that's going to be inefficient in terms of the buffer utilization. If you have a burst of, small packets, then they're going to have to wait longer than they need to, which is not so great. So the high level idea of flow control is that it works kind of like a credit card. When you want to send a packet, you have to, reserve an MTU size block. And then once you know how big the packet is, then you can release that reservation and, pay the actual amount. And then when the operation completes, you pay off the balance. Like I said, this is not particularly accurate in terms of analogies. There's no late fees or interest or rewards miles or anything like that. But it's high level idea of how the flow control needs to work. So the plan that I have at the moment, trying to think of stuff that's going to be relatively small in terms of footprint, but also relatively simple to implement and not too terrible in terms of the logic complexity, because if this has to run at, a few hundred megahertz, it's going to have to be simple. So in terms of the actual scheduling decision, it would be great if we just have credits, right? If we have at least one credit, we can send a packet. Don't want to be checking against some, if you have a big wide comparison, that's going to slow things down. But we want something that we can make back-to-back decisions to start a bunch of packets in a short period of time. So if we just have, okay, we got 4 credits, we can start sending 4 packets. That's pretty optimal. So what we do is we have a credit count that we use to send the packets from that initially starts out at 0. And then we have kind of a separate process that generates the credits for each MTU size that's in the buffer. So basically have a buffer size and a buffer limit. The buffer limit is, a register that you can set on a per channel basis. The buffer size starts out at 0. If buffer size plus the MTU size is less than the buffer limit, we generate a credit and we accumulate the MTU size and the buffer size. When we start the transmit operation, then we consume a credit and we subtract off the MTU minus the packet size, which is, basically the portion of the MTU that we didn't use. When the transmit operation completes, then we subtract off the packet size. So at that point, we've subtracted off a whole MTU. So that corresponds to a credit that we could then, on the next iteration, free up and then generate another, start sending another packet. If we fail at some point in sending a packet, well, we've already paid an MTU, so we can just recycle the credit without having to mess around with the buffer size. So the advantage of this thing is it's super simple, and we can set the buffer size and MTU size in bytes, and we can change the buffer size at any time. And the critical path in the scheduler is just dealing with this very simple flow control credit count. So keeps things very simple. Disadvantage is this, I haven't found an obvious problem with it yet. We'll see. I might bump into something when I actually get deeper into the implementation, but from a first pass, this looks like it could end up working pretty nicely. So this, I'm working on getting all this implemented. Well, I was working on it, backburnered. In another week or two, I'll probably get cracking on this again. Right, so that brings me to some of the kind of research code that's been sitting around in the repo that I finally had a motivation to clean up some of it and get it committed. So for the research we're doing at UCSD, we're doing basically layer 1 switching using an optical switch. And it's important to characterize the performance of that switch so we know that we're actually going to be able to send data through it reliably. And not just that we can, but also when we can send that data through it. So I put together this TDMA BER measurement module, which can be synchronized via PTP with other components in the network. And the test setup is relatively straightforward. You take your switch, your layer 1 switch, and you synchronize the switching of the switch with PTP time. And then you place the PHYs in the FPGA into PRBS31 test mode. And then you use the TDMA BER module to collect bit errors and bin them in an internal RAM based on the PTP time. So what we have is the TDMA BER measurement module that goes on the FPGA, plus the little user space tool to control it and actually perform the measurements. So the original version of this module has been in the repo for ages, but it was not very well written. It's one of these things that kind of evolved organically. Start out with something simple, then you need to add this and that and the other thing, and the original architecture wasn't very good. So what I ended up doing is more or less a complete rewrite, and dropped the logic utilization of it down by about a factor of 2, which is pretty good, and also converted it to use a the new register block setup. So now it's very easy to detect whether the design has this present or not, and also where. Previously, you just kind of had to guess at where it was, which was kind of annoying because that address was different from what it was previously. So I had to do some hunting to find it when we started doing the tests at UCSD recently. So anyway, the updated module is now in the repository, as well as a little control user space tool, which wasn't in the repository previously. So just a real brief overview of how this works. The little utility is called mqnicBert for bit error test. And basically what you do is you specify the PTP schedule start time, the schedule period, time slot period, and the time slot active period. And then it can be set up to either measure the BER across the entire active period in one shot in each time slot and record all that separately, or the time slots can actually be split into much smaller slices. There's no limit to how many slices you have, but it can only measure, actually it's not necessarily 32, it's dependent on the size of the RAM and a couple of other things, but you can measure a bunch of these concurrently. And the output of this is a big honkin' CSV file, which has the error counts and the offsets and whatnot. So you can take that and you can plot it as a heat map, for example, or you can convert it into a time series or whatever. And this allows you to characterize the performance of the layer 1 switch you're using. So this is one of the heat maps that we took a few years ago with the previous generation of optical switch. And you can see right here, this yellow band is where the switch transitions from one configuration to another configuration. So from this heat map, you can get actually quite a bit of information in terms of the performance of the actual switch. If there's any defects in the construction of the switch. The switch that we use is it's built with diffraction gratings that are patterned on basically a hard disk platter that determines which configuration the switch is in. So if there's any defects on that disk, it's going to cause changes in optical power and potentially bit errors. So a lot of this crap that you see is a result of errors or defects on the disk that are generating bit errors. So we can look at that and then go look at the disk under a microscope or whatever and figure out what happened, what we need to fix. You can also see, you can get an idea about the synchronization performance, the time sync. Is the time sync working? Is the time sync not working? If it's not working, then either you'll just get all yellow or this band will be wider than it's supposed to be. And you can also get information about the transceivers, right? How are the transceivers working? Are they taking a long time to lock? Are some of the channels more or less sensitive? Things like that. So you can get a lot of information from this in, I suppose, a very particular use case that we have here at UCSD, but the code is in the repository. So, if that's interesting, you can play around with it. All right. So moving on to a couple of the other things. The application section pass-through that the folks at MLE have been working on. So the idea is that for some application logic, you're going to want to connect that to stuff at the top level of the design. And there isn't really a nice way of passing that down through the hierarchy. So the idea is, okay, can we use some macros to do that? And MLE has been working on that. They put together a pull request to add some macro magic to implement this. And it looks pretty good, but we need to add a couple test benches, just, partially for CI. So I know I'm not breaking anything. And then also partially just, if you're trying to do something weird, integrating to external stuff, you're probably going to want to be able to test that and make sure that all of your custom logic works. So we need a couple test benches to support that. So hopefully we can get that pull request updated with some test benches soon, and then we'll get that merged in. So I don't know if Emily has any comments on that? I'm assuming this is probably a relatively low priority for you guys. So, you know, whenever that pull request gets updated, I'll look at getting that that merged in. All right, so moving on to the development test bed that I'm putting together here. Like I said last time around, I got a 32 by 32 Pilatus optical switch, so I've gotten everything moved over to the new switch. I haven't done too much testing with that yet, but it looks pretty good so far. It's got a much newer controller. Seems like it's actually running Linux instead of this ECOS operating system. So I don't know if that does much to the performance of anything, but it's always nice to have newer software running on stuff. I did test a couple of things through it, and I can get light through it, so that's good. The one downside about this new switch is that it doesn't have power monitors, unlike the other switches that I have. And I guess it's an advantage and a disadvantage. Disadvantage is that you don't have the power monitor capability. The advantage is that you don't take the insertion loss hit of having those power monitors, because you have a coupler. You pass through two couplers with the input and output power monitors. And this one, you don't have the couplers, so you don't have the insertion loss of those. So you can potentially get more loops through the switch if you need to do some complicated interconnection of stuff. But yeah, that's looking pretty good at the moment with everything all set up on there. I also brought my 7060CX switch back from the lab. We were going to use it for something and then ended up not using it. So, okay. So that'll be another device that we can potentially get connected to various things. Another thing I was going to mention. Drawing a blank on what it was now. I still need to get the VPN set up for access to this thing, but the hardware setup is definitely coming together. Oh, that was the other thing I was going to mention. Right. A couple more CFP2 adapters popped up, so I picked them up. These are Monara ones, and these actually work properly, unlike the other adapter that I had. Obviously, the one from Viavi actually works, but these also work at not only 100 gig, but also 25 gig. So that means I now can run both ports on the network tester thing at both 100 gig and 25 gig CWDM4. So that's going to make things a lot easier to deal with in the test bed if everything's all consistent. Yeah, so I think that's about all I got in terms of updates for today. If anyone has any questions or comments, feel free to fire away. Or anything people want to discuss in general. Not sure if we have any anything on the MLEs then that needs to be discussed. I mean, I know you guys have been working on that that pass through. I guess not. I see Joachim, but I guess they don't have anything to say. Okay, fair enough.
I just had one simple question.
Sure.
I'm trying to deal with connectivity between the Xilinx, my Arista switch, and the ConnectX cards. Do you know what's the preferred combination of FEC, no FEC, ANLT or not? Because I don't have a license for that. So
usually I just have FEC enabled and no ANLT because I don't have a license for that either. So yeah, that could be an interesting project for somebody for getting ANLT working, because I don't have that for 10G, 25G, or 100G. I don't know exactly how many devices support ANLT. I think it's usually NICs that do. Switches, some do, some don't. So I'm not sure. The switch that you have, I don't know if it supports it. It might. The switch that I have, I'm not sure either, to be honest. I have had issues with, at least with the Mellanox NICs, not working without RSFEC enabled. If you just directly connect the FPGA to a Mellanox NIC, it's possible that, like, if you have ANLT enabled, then it'll figure it out, and it'll work without FEC. But it's probably better just to use FEC unless you're super latency sensitive, because it does add a little bit of latency. So I think the big thing with the switch is if it supports ANLT, then I guess you can use that to figure out what the connection is. You can at least use that on the Mellanox NIC side. On the FPGA side, you'll probably have to just manually set it to the correct setting. And I think as long as it matches, it should work. Right? If you have FEC enabled on both ends or disabled on both ends, you should be good. But yeah, so I guess you have a test design running on your board now, right? Does that bring out the some sort of register to control the FEC?
Yeah, I'm just using the example design registers, the AXI light registers.
Okay. Yeah, because in Corundum it uses the CMAC core, bare. So there's the DRP registers that control some things, but I know the FEC comes out on pins, so there would have to be some sort of register interface to control that. But you're saying the example design has some AXI light registers in it.
Yeah. So I'm
Okay.
just working off of the registers and those. Worked fine with the loop back, and then when I tried to go to the switch, it was not connecting. So
Right. Well, I mean, the simple thing to do is you can just try both settings, and if neither of them work, then you might need to go into the switch configuration and figure out. Because one thing I've noticed with switches is they tend to. There's a lot of stuff that they don't automatically do, and probably makes sense to some extent what they don't kind of automatically figure out. It's like if you want to run at 25 gig, you usually have to force the port it to 25 gig. So it's possible that switches hasn't figured out.
have you ever gone into the show interfaces by detail? Because it's pretty amazing what they tell you.
Well, I'm sure the switch that you have has a lot more details than the one that I have, right? Because you got a 400G switch, so that's got probably a lot more stuff in it.
But it gives you a breakdown on every lane, and it gives you the equalization parameters, and it gives you effect settings of each lane. It's pretty impressive.
It's pretty cool. They present all of that. I'm sure it's really helpful when they're trying to get their switch chip running on a new board. Like, oh, this lane doesn't work.
It was the death blow to that other card I was using because there were so many problems with trying to get a consistent connection that I set it back.
Yeah, that sounds like you lost a few hairs over that one.
I have so few to spare. Anyway, all right. Well, I'll dabble with that a little more here today.
Yeah. Hopefully it works for you. All right. Does anyone else have any questions, comments, discussion points? Not necessarily related to Corundum, I suppose.
But me, Alex, but
Yeah,
you
sure.
know that I have here at the University of Granada, we have bought like 2 optical switches. So I would like to know just what do you recommend me to start bringing them up?
Right, the Pilatus 16 by 16 ones. Yeah. Well, the first thing to do is to figure out what the what IP address they're using. Right? Because I actually don't know how to do like a reset on them. But I have figured out how to through the Red Boot bootloader, you can dump the EEPROM, and the IP address that's configured is in the EEPROM. So if you go into it's a relatively straightforward thing to do. There should be a serial port on the switch, right?
Yeah.
So you just get a USB to serial cable, plug in there, power cycle the switch when you have a terminal open, and connect it to the serial port, and then you can interrupt the Red Boot thing, and then there's a few commands in there to dump out various things. So I guess I got to double check on. I think you can dump out the EEPROM. I'll have to look up what the command is for that.
Okay.
I have notes of it somewhere, and I think I posted a couple things in the Zulip.
Yeah, I remember.
Mainly so you could go take a look at it.
Okay.
But yeah, so that's the first thing to do, and then once you have the IP address, then you should be able to connect to the thing over over Ethernet, and then you should just be able to use it, I would think. I mean, obviously, it'd be good to dump all the firmware and switch calibration and whatnot, but that takes a long time. Well, I guess one thing that you might need to do with the switch is disable HTTPS, because it's possible that it may or may not have it enabled. Some of the switches I got have it enabled, some of them don't. The new one that I got didn't. Unfortunately, the way to disable it is you have to edit a file on the actual switch, and I can walk you through the process for doing that, because it's kind of annoying. But it's just, you edit one line, then you got to retransfer everything back over to the switch, and then you'll actually be able to connect to it with just any browser, instead of having to find some really old like portable Firefox or something that actually supports the old version of SSL that they implemented on that thing. So yeah, so basically, if you get the IP and you can just connect to the switch and you can pull up the interface, then you're good. If it gives you an SSL error, then we have some work to do. But I've been able to disable it on the couple of switches that I have here, so I can walk you through the process for disabling it on yours. I think the nice thing is when you have the SSL disabled, then it doesn't even enforce a login at all. So you can just connect to the switch and then reconfigure stuff. I mean, I don't know if that's an advantage or disadvantage necessarily. Depends on your point of view, I guess. But
yeah,
that's a characteristic. Yeah. Yeah.
Okay,
and then once you have access to the user interface, then you can set the IP address to whatever you want. So yeah, the main thing is to figure out what it's currently running at, so you can actually connect to it. And then once you can connect to it, then you can change it to something that you actually know that's compatible with whatever network setup that you have. It seems like they don't support DHCP. Even with the newer one, they don't have an option for DHCP, which is interesting. But so I don't know what you might need to do for your setup, if you can put that on the university network, or if you're going to have to do your own little internal.
Yeah, only the local network, so I can put a fixed one, so it shouldn't be a problem.
Yeah, local network is probably the way to go, especially because you got several different pieces of equipment. So if you have it all in the local network, everything can just talk. Yeah.
Okay, nice.
All right.
Yeah, I'll let you know how it goes.
Yeah.
Thank you.
And I guess you'll probably have to go clean everything too, right? Just to make sure that.
Yeah, they are like very dirty. Yeah. I don't know how I'm going to do it, but I think I should buy some stuff for cleaning it properly. At least I have the microscope also. Yeah, I have some stuff already.
Right. Well, I guess the kind of thing where instead of going through with your fancy schmancy cleaner, the first time around, you can just take the top off and pull the connectors from the inside, clean everything with the relatively cheap cleaner. Do that once, put it back together, and then if something gets dirty, then you can use the more expensive poke it into the front panel thing. But yeah.
Okay. So and when opening it, so I should clean everything I see, or?
Well, I mean, it should just be the connectors on the back panel. Everything else
the connectors. So,
yeah. I mean, I guess it depends. So from my point of view, the only thing that really matters is the cleanliness of the connectors, because that's that determines how the thing actually works optically. But if the actual box is dirty, then and you want to clean that, fair enough.
Okay.
But yeah, hopefully everything will work correctly on those.
Thank you.
But yeah, that should make it pretty nice for automating testing of the packet switch design, because you can load up different cross connects on the switch, and then Well, one thing I noticed about these things, I don't know if I remarked on this before or not, it seems like there's a different standard in the telecom world versus the data center world, and they have all of the yours is an SC switch, so that's a slightly different story. Mine are LC. I guess nobody in the telecom industry uses duplex LC fiber or something, because they're all backwards. If you compare to an optical module, right? you line it up the same way. The transmit light on the module corresponds to the input port on the switch. So if you hook it up with your normal duplex fibers, all of the inputs are connected to all of the module. Also, all of the ports labeled out on the switch are hooked up to all of the transmitters on the modules.
Okay, okay. Didn't know
So,
that. Yeah.
Yeah. So I didn't flip flop the connectors on my 32 port switch because that's a lot of things to flip flop.
Yeah.
So it's like if I don't need to, the switch itself is reciprocal. It doesn't matter which way the light goes through it. But with the power monitors, you do need to be going the correct direction for those to work because of the directional couplers. So with the single modes, the 2 16-port switches I have, those have power monitors. So I did flip those around so the power monitors actually work right. But for the 32-port one, I guess you'll just have to remember that when you pull up the thing, everything on the output side is actually inputs to the switch. So it goes backwards. What are you going to do?
Yeah. Very interesting.
But yeah, with the switch that you have, I think it's all individual SC, so you can just plug it in correctly, make sure the light's going the right way through the switch. So makes it a little bit easier to deal with.
Okay, nice.
And I guess you also got that big wad of fiber too, right?
Yeah, I have like 72 fibers or I don't know how many.
Yeah.
And also three packages.
Oh,
like
you got
this
some more
one.
of those.
Yeah.
Sweet.
So like glue everything.
All right. And you tested those modules out in your network tester and that everything's compatible there? There's no weird issues?
This one's not, but I think I have to try them because I have others similar to this or the same one, the same. So, but I think I haven't tested them. I
haven't tried it yet. Yeah, I mean, I'm sure it's fine, but it's just you've always got to double check.
Yeah.
All right.
I have to. I tested with the Mellanox, and they were working fine, but not with the tester.
Yeah, I mean, for the most part, I found that everything works in my tester pretty much, at least at 100 gig, except for these freaking. I got some of these CPAC modules, which are CWDM4, and the adapter. This thing doesn't work at all. So I don't know. The Cisco switches must have to do some sort of initialization procedure that this thing is not doing. So I don't know. Anyway, I finally got the all of the CFP2 adapters that actually work. So that's good.
Yeah, sure.
Yeah. I mean, I guess I now have 3 good adapters, but only 2 ports on my tester. So okay. better to have an extra one.
Yeah, who knows?
All right. Well, anyone else have any questions or comments? I guess right, according to the survey, our next meeting is going to be on Wednesday, February 7th. So it's a bit less than, it's more than a week, less than 2 weeks. And then from that point, it'll be once a month. So I guess we'll have to figure out what's going to make the most sense for the Switch meeting. We could do, later in the day or something like that after the Corundum developer meeting, or we could do a different day or different week or something. I'm not sure.
For me, it's the same. I mean, whatever makes more sense to you.
Doesn't make much difference. Yeah. All right. Yeah, I guess I'll have to think about that. I mean, maybe it makes sense to do that every 2 weeks or something because you're actively working on stuff, right? So
yeah, I mean, for me, it could be better, have like more feedback and more collaboration here.
Right. I guess the other thing I got to figure out too is in terms of the scheduling, or in terms of the handling the video stuff, because what I'm probably going to do for the Corundum developer ones is record both sessions, but probably only upload one of them. So I don't think people want to listen to the same thing twice necessarily.
Maybe you can cut the last part of discussion and insert it on the end.
Possibly. That was the other option I was thinking about. So not sure, but that does mean more work for me. It's just sure. When I upload, it's like, okay, that's easy. If I got to like cut and splice, I'll think about that. There might be a simple way of doing that. Maybe like FFmpeg or something. I can just,
Yeah.
I don't know, something simple.
Okay, good.
Quentin, did you want to say something? I noticed you came off of
No,
mute.
no, it was just to be sure. It's 9 p.m. on Wednesday, Wednesday 7th, 9 p.m. For you, it's the same hour. It was previously.
So the idea is that we're going to do it twice.
Yeah,
I'm
yeah.
going to do one at 9 a.m. and then one at 9 p.m. on Wednesday.
Okay, so
So 12
actually
hours
it's
apart.
it's 9 p.m. Right now for you.
It's
No,
9
9
a.m.
a.m. 9 a.m.
Yeah.
Okay. So okay,
Yeah.
all right.
So it'll be the same time, but on
Yeah,
Wednesday,
on
plus
Wednesday.
one
Okay.
12 hours later.
Yeah,
So,
right.
So yeah, I mean, if that second slot is like super late or early or middle of the night for you or something, you know, that's not a big deal. It's more for people in Asia or something where I think the current slot ends up at like 2 or 3 a.m.
Yeah.
So yeah.
Okay. All right.
So does that seem reasonable?
Yeah, sure.
Okay. All right, sounds good. Not sure if anyone else has any questions or comments. I've noticed a couple of new names. I don't know if people want to introduce themselves or say anything.
Hi, I'll go ahead.
Hello, Burhan.
Yeah,
How you doing?
Yeah, I'm doing fine. So I'm from India, Bangalore.
Nice.
Yeah.
What time is it for you right now?
It is like 11:16. Not that late.
Oh, okay, that's not too bad.
Yeah. I come from RTL design and design verification background.
Okay.
And yeah, I would like to contribute more on CocoTB side, testing verification side.
Nice.
Possible. So just figuring things out, how means the flow of the design is.
Oh, okay. Oh, pretty cool. Yeah, I know. Well, I mean, I think in terms of Corundum, there's probably various things that don't have test right now that we could certainly test, and there's probably some other interesting stuff that that we could do. I know someone's been working on how to connect the PCIe side of stuff to QEMU, so you can run basically Linux and QEMU, and then that will talk to CocoTB and then talk to the design that way. Need to check up on what the status of that is, but I know that somebody's chipping away at that. I'm not sure what else we could do that might be interesting. But yeah, I mean, from my point of view, I do some verification type stuff, but it's basically just whatever I need to do in order to get the design implemented, basically. But you know, if you're approaching this from a verification perspective, I mean, I think the idea is to try and poke holes and find bugs and things, right? So yeah, whatever you want to take a look at, you know, feel free to ask questions on Zulip or whatever, and yeah, should be good.
Yeah, sure. Thanks.
Well, thanks for joining the meeting and taking the time to introduce yourself.
Yeah.
Yes.
Hey, I'm Ben.
Hey, Ben, how you doing?
Doing pretty good. So I'm currently with Pricing Communications, and we're working on using Corundum as the base architecture
Oh,
for.
right, with Kent, right?
Yeah.
Nice. Yeah, I've spoken with Kent a couple times. Not bad, not bad. So you're going to be using Corundum potentially?
Yeah. We decided on going with Corundum for the base architecture for the NIC. It's going to be an Alveo U200 board.
All right, sweet.
Yeah. And then we're building other stuff on top of that.
Right. Well, that should be good. Is this going to be mainly for Ethernet, or are you going to try to connect it to the Rapid IO stuff?
It'll probably Rapid IO and possibly Fusion as well.
Okay. Well, pretty cool. I mean, if there's anything in particular that needs to be implemented in the core of Corundum, I'm certainly willing to certainly open to discussing that sort of thing. So, depending on what you guys are doing and what your needs are.
Sure.
certainly
Yeah.
open to
If
discussing
anything comes
stuff,
up,
so.
we'll be sure to ask.
Yeah, definitely.
Yeah.
All right, well, that's pretty cool. So you're located in Oregon then, I guess?
Yeah, in Oregon. I'm
Portland,
I'm in Portland right now.
Oh, very cool, very cool. Yeah, my I got some family in Lake Oswego actually, so.
Oh, nice. Yeah. Yeah, I'm right in
Oh.
Beaverton. So right near
Oh,
there.
nice, very cool.
Mhm.
Yeah, I guess it was I was just up there over the winter break actually, so it's a little bit dicey coming back, right? I think I flew like 2 or 3 days after that door incident.
Yeah, it was a big yeah. Quite the fiasco.
Yeah.
Yeah,
Well, nice. Thanks for joining the meeting and introducing yourself. And feel free to ask questions or whatever on Zulip or in future meetings.
sure.
So yeah.
Will do. Thank you very much.
All right. All right. So does anyone else have any? So I guess there's one other person. I don't know if you want to introduce yourself or not. Can?
Hello,
Hello?
hello. I am Can. In Turkey, we are saying Can. Sorry. I am joining from Turkey. I designed an AFDX network in my previous job, which is the deterministic network, like an TSN network. And now I am searching the new things, and I want to discover the new features, and that's because I am here.
Okay. Very cool. Very cool. So you said you worked on some stuff that's similar to TSN. I know Carlos has been doing some work with TSN.
Ah, I don't know.
Well, Carlos is on the
Carlos?
call right now, right?
Yeah. Hang on.
Sorry.
Yeah. But
Yeah.
continue.
Just AFTX is not, includes the time synchronization, but in my feature work, I want to add an time synchronization to on it to improve the determinism. And I'm searching the TSN network to find the common things and the by the way, TT Ethernet also the near it's very middle point of both of them, but it's the restricted standard and for the aerospace industries, and but I'm not good at the TSN. I am just learned the and work on the FTX network. Yeah, I am very new. Sorry, I'm very new. It's yeah.
Yeah, I was just trying to figure out some more information about that network that you said you're familiar with. So it's AFTX, AFDX.
Yeah, AFDX. Yeah, it's an Airbus standard.
Avionics Full Duplex Switched Ethernet, AFDX.
Yeah.
Oh,
Yeah.
okay. Patented by Airbus. Okay.
Yeah. In my previous job, we have and my team implemented the PCI side and the SF the SFP
The wire
side. You know,
side.
the wire side. Yeah.
Yeah.
And
Which
both
could be
of
a
them
fiber
wire, but
as it were, but it's a wire. Yeah.
yeah. And then also the driver, the computer driver and the optimizations.
So you basically
We
did the
have
whole
done
thing. Okay.
Yeah. I and also the verification side, UVM. Yeah, we have used.
Yeah, for safety critical
lots
stuff,
of,
you gotta be absolutely sure it's gonna work properly, right?
Yeah, and also my master thesis is about it. I searched to improve the latency decrease the latency, I mean, and I worked also on it.
Okay. Just what data rate does that run at?
1 gigabit per second, but the
What?
standard
Okay.
itself is 100 megabits per second. Generally, in nowadays, the companies are increased 1 gigabit per second.
Right. Yeah. I mean, obviously, faster is better, especially with the number of systems that you might have on a, on a plane or whatever. Yeah, need a lot of bandwidth for everything to be able to communicate effectively. So, yeah. Well, I guess Corundum is a couple of notches higher than that, right? Kind of the lowest rate Corundum
Yeah.
runs at is 10G right now. We are hoping to get support for gigabit as well. The idea is to set things up such that you can run, some combination of 1, 10, and 25 on the same quad, which requires a bit of additional work, but could potentially be useful for backwards compatibility stuff. But anyway, yeah, that's definitely the considerations are a little bit different for 1 gig versus 10 gig or 100 gig. So yeah, and then so you're saying that that this standard, the FTDX, it doesn't have any time sync. So how does that work then if you don't have any time synchronization?
In the aircraft, RTOS systems has its own the time slots, and some processes are running at that own time, and the packets are sending with a limit. For example, one program sends an packets 100 times per second, and you know it, and it's a maximum limit, for example. You can configure your network that for that link, for example, it's a 100 packets per second, and also the bytes, 100 bytes, for example. And some token based and algorithms are implemented on it to ensure the end-to-end limits and bounds are bounded, and it's just about that, not a specific time. And some jitters
Okay, I
are
see.
very known. Yeah, some jitters also known and given in that protocol.
Okay, so it's basically kind of enforcement in terms of who can send how much traffic. And as long as, your enforcement is accurate, then you're not going to run into a congested network. Okay, I see. So it's a rather different setup from TSN, which has explicit time slots where specific traffic can be sent, and nothing else can be sent during that time slot. Okay.
And Ethernet like things, it's at the midpoint. I said it take the TSN's time slots. For example, first 100 milliseconds like TSN, and the remaining time like AFDX. The protocol it's mixed up, but both of them.
Okay, I see. So that kind of gives you the best of both worlds, sort of. So you can get the dedicated time slots at TSN, and then whatever is left over that's maybe a little bit less critical, but still important, where the jitter is less important, then you could use the other technique. Okay. Well, that sounds pretty cool. Yeah, maybe you and Carlos can exchange some ideas, because Carlos has been working on some TSN implementations, I guess. Well, Carlos, so you did a paper on that, or that was your master's thesis, I think, or what was the story with that?
Yeah, master thesis, and also I had a small paper presenting one of the solutions that we have here in our group that was running TSN at 1G. And now, part of the main core of my thesis, of my thesis, is to have this high performance TSN version. This is why I am trying to integrate it into Corundum, and next, early in the future, into the switch. but it's looking for high performance, high bandwidth also, to see if we can control the latency also, maybe at some cycles level.
All right, so you're shooting for like 10G, but if you can make it work at 25G, you know, that would be a
Yeah, why
bonus,
not?
So
Yeah, but the minimum is 10G, yeah.
well,
So yeah, maybe in the future we can exchange some of the ideas in where if we are going to work in similar stuff.
yeah, maybe potential opportunity for collaboration, you know, maybe.
Yeah. Sure.
All right, well, that's very cool. So you said your name is John, right? Am I pronouncing that correctly?
Yeah, John. Yeah, like
John.
John. You know.
Yeah,
Yeah.
okay. I guess I'm not familiar with how some of these names are pronounced in other languages. All right, John, I'll remember that.
Yeah, it's not very normal. Sorry. Yeah.
All right, well, thanks for taking the time to tune in and introduce yourself. If you have any questions, you know, feel free to bring it up on Zulip or whatever. Yeah. All right, does anyone else have any questions or comments? Or I guess we're at an hour, so we can adjourn for today if
Yeah,
nobody else
one
has anything they want to
question.
add. Oh, yeah, sure.
Just to know, we will be having the meeting of the Switch developer meeting next week, or we will wait after the first meeting of February?
I mean, I guess we could. Yeah, I'm just trying to think of what makes the most sense here. Because we could do the Switch developer meeting on Monday.
Or maybe you want
I don't
to
know.
look like a restart of everything, and you prefer to wait until.
Yeah,
so this is fine.
I'm just trying to think of what are the potential schedules that we could do, right? We could keep doing the same thing every other week on Monday, but it might be better to use the same time slot, right? If we do the 9 a.m. times, I think, you know, if people are going to set aside a weekly time slot for something, it probably makes sense to try and keep it the same day and time.
Yeah.
So
Okay.
I guess what we could do is what I was thinking with the meetings is that if people think once a month is not enough, then I could potentially do, you know, maybe the first and third Wednesday of every month. So it's closer to 2 weeks, but you can just look at the calendar and go, oh, okay, it's here are the dates. So what we could do for the Switch meetings is, you know, do the second and fourth Wednesday. Right. So
Okay.
So what the next Corundum developer meeting would be the 7th. So then we can do Switch developer meeting the 14th and 28th, for example. Yeah. Something like that.
Okay, sounds good.
And then just do the 9 a.m. time slot for now.
Okay, yeah.
Yeah. That could work pretty well, I think. But yeah, the question is, are we going to meet next week or not? Well, I mean, we have the Corundum developer meeting on Wednesday, so meeting on Monday and then again on Wednesday is probably a little close. So, all right, we'll skip that one. Unless you have something in particular you want to discuss. There's something.
I mean, I have been working on all the stuff, the hash tables and that, but maybe I can wait. I mean, I have lots of stuff also setting up all the test bed with the new optical switches.
I mean, it's like if you have something interesting or useful to report or something important to discuss,
it can wait.
It can wait. All right. So we'll do that then. We'll do the Switch developer meetings
starting
the
14th.
Second and fourth Wednesday. Yeah. Okay. We'll see how that works.
Yep.
All right. Sounds good. And I'll make a Google calendar later this week probably that people can just add because then you get a notification or something. All right.
Okay, nice.
All right. Does that sound reasonable?
Yep.
Okay. Sounds good. Well, thank you everybody for tuning in today, and I guess we'll go ahead and adjourn for today, and we'll see you guys what, February 7th in a week and change.
Okay, thank you.
Okay.
See you guys.
Alright.
All right. See ya.
Bye.
Bye.
Okay, see you.
See ya.